Assalamualaikum warahmatullahi wabarakatuh and uh, very good morning. Very sorry not to have class today as I promised to you through the WhatsApp. I'm a little bit busy, but I prepared this video so that you can watch the video any of at any of your free time. So, so I think this is could be more flexible to you and also to me. So let's continue the class with the slide with the chapter 2. I think we are we have done the this chapter 2-1. Now we are continue to the chapter 2.2 about the DC and AC meter. So for this subchapter 2.2, at the end of this subtopic, you should be able to explain the purpose of shunt across a meter, analyze the DC meter circuit and insertion effect of a DC meter. So let me put the slideshow. What is DC ammeter? A device used to measure current. Ammeter, remember that ammeter is current. Placed in series parallel with the circuit. Very common in lab. Unit ampere, milliampere, using the principle of the ensemble meter movement with slight modification. So this concept of the ensemble has been explained to you in the previous chapter. If you can go back uh, to the previous material, chapter 2.1, and see how this concept of the ensemble meter movement. So this is the conceptual of ammeter. Main part restriction. This is the uh, illustration of a water flow. You have a main pipe, then got the restriction here, so that then got the output, and then you have the other flow here, bypass with a paddle wheel, and then you can see the water flow. So it same goes to the current flow. Main wire, you have the resistance. In when you put the ammeter, where it is actually you measure the current flow into the shunt here, then you get the reading of the meter. Placing a low resistance in parallel with the meter movement resistance to increase the range of current that can be measured by the meter. RSH is shunt resistor, RM is meter movement resistance. This is the ensemble meter uh, movement, RM parallel to shunt resistor. To limit the amount of current in the movement coil by shunting some of it through R shunt. So this is the concept of the ensemble movement. Okay, in the DR solver movement, it consists of the RM, which is internal resistance of the meter movement. In ISH is I current through shunt current. Then this is the current where you put the ammeter. So this is the all the notation of the term that used in DC ammeter: RSH, RM, ISH, IM, and also I. So RM is internal resistance. If you want to measure the voltage meter, VM, VM equals to current through IM multiplied by RM. V shunt equals to VM, which VSH equals to VM. So ISH equals to I minus IM, which is RSH equals to R shunt resistor equals to VSH divided by ISH, and finally you get this formula. So this is all the formula to describe the DC emitter. Ratio of current deflection to full deflection, multiplying factor N equals to I divided by IM. So R shunt equals to Rm divided by N minus 1. So to realize the as all the equation just now, we can see here the example. Calculate the value of the shunt resistance required to convert a 1 milliammeter movement with 100 ohm internal resistance into 0 to 10 milliampere ammeter. So this is the answer. So by using the previous equation here, so you can calculate the value of the shunt resistance required to convert a 1 milliampere meter movement with a 100 ohm internal resistance into a 0 to 10 milliampere ammeter. So you can see you can use the equation just now and just uh, fit into the value into the parameter into the equation, then you can get the R resistance 11.11 ohm. Example 2, you can try this example by yourself by looking at this equation of DC ammeter. So the answer is 0.801. So next is a DC ammeter multiple range, which is also known as the universal shunt used on a multiple range ammeter. It is eliminate the possibility of the meter movement being in the circuit without any shunt resistance. It may be used with a wide range of meter movements. There are two types of multiple range of DC ammeter, which is one is a parallel shunt, second is Ayrton types of DC ammeter. So what will happen if the switch lost contact during switching from one shunt to another when carrying a current? Okay, so this is the parallel shunt of DC ammeter, the connection. And, it is connected to the R1, R2, RT, R4. The question is what will happen if the switch lost contact during switching from one shunt to another and carrying current. To eliminate that possibility of the moving coil to be in the circuit without any shunt resistance, then we use the what we call it Ayrton shunt. So this is the Ayrton shunt load slide. So this is a figure 3 emitter using Ayrton shunt. So this Ayrton shunt is trying to avoid the problem of lost contact during switching from one shunt to another when carrying a current. So this is the equation or the formula to measure the R shunt, which is RA plus RB and RC, where you will get that R shunt equals to Rm divided by N minus 1. So in the picture above, the meter movement needle is shown pointing somewhere around 35%, right? Of full scale, 0 being full to the left of the arc and full scale being completely to the right of the arc. So if you look at this figure, the needle is showing pointing somewhere around 35%. An increase in measured current will drive the needle to point further to the right, and decrease will cause the needle to drop back towards its resting point on the left. So this is very basic uh, definition of the DC ammeter. So at point B, here, right, by using the equation of RB plus RC, where you get the RB plus RC is parallel to RA plus Rm at the point B. So this is the middle sensitive range at the point B. So VRB plus VRB plus RC. So this V, RB plus RC equals to VRA plus RA, right? So RB plus RC multiplied by I2, this is the I2 minus by IM equals to IM RA plus RA. And then finally, you will get the final equation RB plus RC equals to IM multiplied by RSH plus RM divided by I2. So please remember this equation, and also please understand how to get this equation from this Ayrton shunt. At point C, you will get the equation RC equals to IM multiplied by RSH plus RM divided by R3. So this is derived from the circuit where you get the RC equals to IM RSH plus RM divided by I3. So finally, you substitute the equation F into E, and you will get the RB, and also you can get the formula of the equation of RE. Example 3. So you can try this example 3 to understand how to get the RA, RB, and RC from the Ayrton shunt, and calculate the value of RA, RB, and RC as shown, given the value of internal resistance Rm equals to 1 kilo ohm and full scale current of the moving coil equals to 100 microampere. So the required range of currents are I1, I2, and also I2. So you can go through this solution, where this is the solution that use all the equation that I explained to you just now. And finally, you will get this, all the RE, RB, and as well as RC. Okay. So this is the next example. You can try by yourself to calculate the value of our resistance R1 through R3 in the circuit shown below. Okay, by Ayrton shunt as well. So this is example 5. Okay, in your free time, please try this example and try to understand all the equation used in in the example. Okay.